All right, today we're going to take a look at how to find the area under the standard normal curve. And what I have drawn here is a normal curve, and you have mu in the middle there. Your median's also in the middle, so you know 50% of your data lies to the right and 50% of your data lies to the left. And here I have marked off 1 standard deviation, 2 standard deviations, 3 standard deviations, and likewise on the flip side. Now, within 1 standard deviation left or right of the mean, you have 68% of your data. All right. And within 2 standard deviations, 95% of your data will lie. And within 3 standard deviations, 99.7% of your data will lie. The question is, though, what if you're like 1.5 standard deviations from the mean? This is no good. The empirical rule becomes not as useful as you would like it to be. So what we're going to do is we're going to use a chart to look up these values in the area under the curve. All right, so suppose I was giving z is less than or equal to 2.43. Now, keep in mind, if you don't have z, you're going to have to find it. It's just x minus mu divided by your standard deviation. The raw score, whatever it was, divided by the population mean, divided by the population standard deviation. But I'm giving you z, so I want to find the z value is less than 2.43. All right, if we draw a picture, 2.43, remember 0 is right in the middle, so 2.43, we'll just ballpark it. It's right around here. And I want the area left to that, so I want this shaded region. What you're going to have to do is flip to your z-score charts. All right, and for me, it's called Table A. And I have one chart with negative z's on the left here. You can see these are all negative values. And the next page is all positive values. All right, and what we're going to do is, given this z-score, 2.43, these charts give us the area to the left of a specific z value. So if you look at the picture right here, given this specific z value, these charts give us the area to the left of it. And you can see z is over on the right half of the data because these are all positive z-scores. Z-scores lie to the right of mu, which would be 0. And here are the negative ones, so z is to the left half of this graph. All right? And so we had z was 2.43. So what we're going to do is, on this graph, you're going to go over to 2.4. So we're in this column right here. And on the top, line it up with 0.03. 2.43 is right here, 0.9925. So we could say that 99.25% of the data lies to the left of 2.43. Now, in this next example, suppose we wanted the area between, let's say this is negative 1.67. I'm just ballparking these negative 1.67. I know since it's negative, it's going to be to the left half, and 1.44, well, since it's positive, it's going to be on the right half. I want the area in between this. All right, and what we're going to do is we're actually going to find the area from here and down, and then we're going to find the area from here and down, and then we want this left over. So what we'll do is we'll just subtract the two. So we're going to look up negative 1.67 on our chart. All right, and negative 1.67, so here's negative 1.6. I'm going to scroll over to 7, so I have 0.0475. All right, next we're going to look up 1.44. And here's 1.4. Scroll over to 1.44. All right, this is just a hundredth spot up here, so that's 0.9251. All right, and we're just going to subtract the two. And when we subtract them, we get 0.8776. So 87.76% of our data will lie between negative 1.67 and 1.44 standard deviations from the mean. And the last one here, we have z is greater than or equal to 1.9. And so suppose 1.9 is, right around here. We want the area greater than this. Right, now, remember, before I told you the charts only give you the area to the left of the curve. All right. So when I look up 1.9 on my charts, it's going to give me this area. Well, since we know the area under the curve is 1, it's always 1, if I found this section, I could actually just subtract that from 1, and I'll be left with what's left over. So we're going to look up 1.9 as usual in our chart. All right, that's 1.90, so it's right here, 0.9713. And we're going to subtract that from 1. And when we subtract it, we get 0.0287, and so you could say that 2.87% lies to the right of 1.9.